my work focuses on nanoscale manufacturing, and this applies to a variety of applications such as electronics, sensors, and also energy storage such as batteries and other types of devices. Trying to take advantage of how nanoscale can enhance and can improve all these kind of devices. For example, when we use nanotechnology, such as nanoscale particles and fibers and so forth, then we can significantly enhance the battery life. We can significantly reduce the charging time, and we can also increase the battery capacity as well. And this is simply by just changing the materials and using our technology to manufacture these batteries. The current research on making more efficient energy storage, whether it's micro or large, was inspired by the need for NASA and for space applications, where if you use a battery in your daily life, in a laptop or a watch or any application, if there's a problem, you can replace it. You can charge it very easily. If it's from space, you cannot, in a satellite, for example, you can't do that, and it has to last for 20 years. Not only that, it charges using solar energy, which means it has to face the sun. But they only face the sun when they go through around Earth. They're facing the sun for about half an hour or so. That's how long they have to charge. So your battery has to be fully charged in half an hour, which is very difficult, and it has to last for 20 years without losing so much capacity. So the only way to do that is to actually use nanomaterials and to arrange the nanomaterials in such a way that increases the surface area and gives you very high power density, which means long life and fast charging, and also higher energy density, which means more capacity. And so that was really inspired by space applications, but it has a lot more uses in daily applications also, because it's better to have a battery that charges fast. It's better to have a battery that will actually last longer. So definitely, even though the inspiration was for space applications, but it definitely has a lot more utility or uses here, on Earth. Basically, for this application, for the battery applications, there's a lot of problems with batteries. Now batteries are much better than they used to be many years ago, 5-10 years ago. But still, the charging still takes time. The battery loses capacity very quickly. So, for example, most laptops you have to throw them away after 3 years, and the technology we're working on will last 20 years. So without much fading. Fading means losing capacity. So you start with a battery at 100%, and then after 300 cycles, which means a few years, it could be goes down to 50%. It shouldn't go down to 50%. It should go down maybe to 80% or 90%, which means that you will not notice the difference. But we definitely notice the difference. So this technology actually allowed the battery to be at high capacity without fading for a long time. Would be fast charging. Imagine if you put your laptop and in half an hour it's fully charged. Your phone would be fully charged in a very short time. Especially the tiny batteries with, for example, like the earbuds and so forth. Those actually are very tiny batteries. And we also showed that you can use the same technology to increase capacity and increase the lifetime of the battery. And right now, the lifetime of the battery, depending on how many times you charge it and discharge it, and after a few cycles, its battery is just doesn't last very long. There's a need for technology to improve battery life. Also, we can reduce the size of the battery and the weight of the battery because of the materials we use. So not only you increase the size, you decrease the size and weight, so it's much more compact. Remember, the battery is one of the biggest parts of your laptop is the battery, actually, and your phone also, and so reducing that while increasing the capacity, while decreasing the, making last many years longer, and making it charge very, very quickly is a huge advantage.